Hi, this is Dr.L. Bharathi, Professor and Head, Department of ECE, the Shanmukha College of Engineering and Technology, Sangagiri. Today's session, I am going to discuss about amplitude modulation. Before going for the modulation technique, let me introduce about the basics. What is communication? Communication is the process of exchanging the information from one place to another place. That information is transferred from one place to another place through media or channel. Based on the channel or media, it is further classified into mainly two types. One is wire medium or wireless medium. If the message is conveying through wire medium, so called it is wire communication system. Example, coaxial cable, telephone communication system and optical fiber communication system. Suppose if the message is communicating through wireless or air medium, so called it is a wireless communication. It is nothing but uh, AM communications, amplitude modulation communication is one of the best example. Now here we have given a simple block diagram of communication system that is called elements of communication system. It consists of information source, transmitter, channel transmission medium, receiver and destination. So in the channel transmission medium connected with noise. What is happening here? That information, okay, is getting from the source that is being connected to the transmitter. There will be the modulation taken place and boosted up and transmitted from the antenna through channel or medium. Now it is being traveled for long distance. At the destination, there is a first circuit, so called it is a receiver. The receiver is there to detect only the weak signals or identify the weak signals, then connected it over to the destination part. There will be lot of process be taken place and to recover or retrieve the signals. During the transmission, there will be a noises added with the signals that can also be filtered out in the receiver part to get the information. This is a overall communication system. Next, we go to the modulations. What do you mean by modulations? What is a necessity? Whether it is required? Yes, of course, it is required for sending the signals long distance. What do you mean by modulation? Modulation is also one of the process to modulate the signals, okay, according to the message. So, what type of signals? For modulations, we need two signals. One is a carrier, another one is a message signal. The carrier signal is going to be changed or modulated in according to the message signal. This phenomena is called as a modulation. Okay, this types of modulation we have a different category like continuous wave modulation, pulse digital modulation, amplitude modulation, angular modulation, digital modulation, analog. The types of modulation classified in two types. One is a continuous wave modulation or analog modulation. Another one is pulse digital modulation. Continuous wave modulation or analog modulation further classified into two types: amplitude modulation, angular modulation. That angular modulation further classified into two types. One is a frequency modulation, another one is phase modulation. Come to that digital modulation, there are different types: digital modulation and analog modulation. The pulse code modulation and again that analog modulation classified into various types: pulse amplitude modulation, pulse duration modulation and pulse position modulation. There are different types of modulation in both analog as well as digital. Types of modulations. There is a modulation. It is nothing but, again I am telling you, the modulation is defined as the carrier signal is modulated in according to the message signal. Okay. In analog modulation, there are only two different types: amplitude modulation AM and angle modulation. Amplitude modulation AM further classified in different types: amplitude modulation double sideband full carrier, amplitude modulation double sideband suppressed carrier, single sideband modulation, vesicle sideband modulation with respect to AM. Coming to that angle modulation, classified into two types: frequency modulation FM, phase modulation PM. The frequency modulation, again two types: narrow band frequency modulation, wide band frequency modulation. Phase modulation, again there are two types: one is narrow band phase modulation and wide band phase modulation. What is a necessity or need for modulation, or let me say the advantages of modulation? The first point is we need to go with the modulation, or one of the advantage of modulation, we say the first point is the size of the antenna height may be reduced. Say for example, here I have given some example. For efficient transmission, the antenna size approximately equal to lambda by 2, of course. As we know that C equal to F lambda and C equal to 3 into 10 to the power 8 meters per second, if you go with the frequency, message frequency 5 kilohertz, if you wanted to transmit, then the lambda by 2 equal to C by 2F, which is equal to 3 into 10 to the power 8 by 2 into 5 into 10 to the power 3, that is equal to 30 kilometer. That is the uh, antenna size. If you want to transmit a 5 kilohertz message frequency, 5 kilohertz signal, we need to have 30 kilometer length of antenna. I think it is impossible to design, construct this much of length if you want to transmit 5 kilohertz low frequency. At the same time, if you want to transmit a high frequency 10 megahertz frequency, high frequency, the lambda by 2 antenna size is only 15 meter. See that for low frequency we need 30 kilometer, for high frequency we need only 15 meter. I think it is practically possible to have antenna size 15 meter. That is the reason we always go for higher and higher frequency. In order to go with the higher and higher frequency, compulsory we need to modulate our message. We need to go for modulation with the carrier frequency and message frequency. So this is one of the major factor going for modulation. That is, antenna size can be minimized. Then second one is multiplexing. Several messages can be transmitted simultaneously for long distance. For that we need to have modulation. Then adjustment of bandwidth. Of course, we need to have adjustment of modulation in order to increase signal to noise ratio and minimize the noise level. Then ease of radiation. Signal level can be radiated in easy way. These are the 3-4 points we can go for necessity of modulation, or also we can say these are the advantages of modulation. Now go with amplitude modulation, that is AM double sideband full carrier. In amplitude modulation, the amplitude of the carrier is changed according to the instantaneous value of the modulating signal. So in a better way we can define the term. What do you mean by amplitude modulation? The amplitude modulation is defined as the amplitude of the carrier is changed in accordance with the amplitude of the message signal. The carrier signal is a high frequency, message signal is lower frequency. The simple diagram also we showing here. There is an amplitude modulator. We need two signals like M of t message signal, C of t carrier signal. We will get amplitude modulated signal here. The diagram shows here there is a message signal low frequency, there is a carrier signal high frequency, there is a modulated signal. See here the message signal, the first waveform showing is a low frequency. The message amplitude is changing after some time interval. Okay, then message amplitude is increasing, then decreasing, then further decreasing, then slowly increasing. Okay, then the carrier signal, high frequency signal started from beginning itself. There is no time gap. Okay, right. Here we are showing high frequency carrier signal. As per the law, as per the concept, amplitude modulation, the amplitude of the carrier is going to be changed in according to the amplitude of the message signal. What is happening here? In the first beginning itself, there is no message signal for a particular time period here, but there is a carrier signal in the particular time period. What is happening? As per the amplitude modulation concept, since there is no message amplitude here, since there is no message amplitude in the time gap, there is no changes in the amplitude of the carrier signals. The same carrier is generating here up to the particular time period. After the particular time period, the message amplitude is going to be increases. The message amplitude is going to be increases. Thereby, the carrier amplitude also increases gradually according to the instantaneous amplitude of message signal. Likewise, the carrier amplitude is changing according to the message amplitude. We are obtaining amplitude modulated output signals. See that diagram shows amplitude modulated double sideband full carrier envelope. Okay, right. Here we are getting maximum voltage. Here we are getting minimum voltage. So that amplitude is increasing maximum whenever the maximum amplitude occurs. The carrier amplitude is going minimum whenever the carrier message amplitude is going minimum. Whenever the message amplitude is 0, there is no changes in the carrier amplitude. This is a three concept we keep remember. One is whenever the message amplitude is 0, there is no change in the carrier amplitude. Whenever message amplitude goes high, the carrier amplitude also goes high. Whenever the message amplitude goes very low, the carrier amplitude also going very minimum. Thereby, we determine maximum voltage, minimum voltage from the amplitude modulated signal. From the maximum amplitude and maximum voltage and the minimum voltage, we determine what is modulation index or depth of modulation or percentage of modulation. That it is showing here modulation index or depth of modulation or percentage of modulation. That modulation index ranges from 0 to 1. If we say that the modulation index is 0, modulation index 0 means there is no change in the carrier amplitude. It means there is no message signal. Suppose the modulation index changes to 0.5. In terms of percentage, we say that 50%. It means that there is a message signal, there is a carrier signal. The carrier amplitude is changed to 50%. If it is m equal to 1, carrier amplitude is changed to 100%. This is what the meaning of modulation index. It is nothing but the formula is m equal to Vm by Vc or m equal to Vmax minus Vminimum by Vmax plus Vminimum. How to measure Vmax and Vminimum? That is showing in the diagram here. See here Vmax, Vminimum, and by taking the ratio, we will determine what is modulation index. Ultimately, what we try to understand about modulation index, how far the carrier amplitude is going to be changed according to the message signal. Okay, this is what explain about modulation index. See, as I told you now, m equal to 1, modulation index 1, modulation index greater than 1 or less than 1. If less than 1 means maybe a 0.9 or maybe a 0.5 or maybe a 0.2 or maybe 0.1, something like that. If it is the case, the signal, amplitude modulated signal under modulation. Say that under modulation. Okay, suppose if we say that you see here carrier amplitude is increases maximum and minimum, not coming to 0. This is under modulation. But carrier amplitude is 0, reaches 0 here. See, this is 100% modulated. Carrier amplitude is 100% modulated. That's what say that m equal to 1, critical modulation. But here m is greater than 1. Say for example m equal to 1.2 or 1.3 or 1.5, something like that. It is a over modulation. It is getting overlap here. Okay, this is what call it as a amplitude modulated signal under modulation, over modulation, and critical modulation. Then frequency spectrum from the amplitude modulated signal. From the amplitude modulated signals, we may get three components. We may get three component. If you say it is in the frequency spectrum, see here carrier component and upper sideband component and lower sideband component. The carrier component having carrier frequency with a higher amplitude voltage, high voltage. Then upper sideband frequency having Fc plus Fm with a half of the voltage of carrier voltage. Then lower sideband component having the amplitude just half of the carrier amplitude, carrier voltage. Okay, so Fc plus Fm upper sideband, Fc minus Fm lower sideband. The voltage of the upper sideband and lower sideband is a half of the carrier voltage. Okay, this uh, here we try to understand one thing. The carrier frequency is 10 kilohertz. Example, message frequency is 5 kilohertz. Example. So Fc plus Fm. If we say that the carrier frequency 10 kilohertz, that upper sideband frequency will be 15 kilohertz because 10 plus 5. At the same time, the lower sideband frequency will be 5 kilohertz because 10 minus 5, 5 kilohertz. This is how we determine how to get the frequency spectrum and bandwidth also. See here, the bandwidth BW equal to 2Fm. Okay, from lower sideband frequency to upper sideband frequency. What is the difference here? 5 kilohertz. What is the difference here? 5 kilohertz. Therefore, the bandwidth, the total bandwidth equal to 10 kilohertz. What is FM message frequency? 5 kilohertz. The bandwidth will be twice of message frequency. So 2 into 5 equal to 10 kilohertz. Okay, and one more thing we need to understand here, the carrier frequency and upper sideband frequency. The upper sideband frequency always deviated and lower sideband frequency is also deviated from its carrier frequency. How much the carrier frequency deviated towards upper sideband, towards lower sideband? It is a rate of message frequency. 5 kilohertz is deviated from carrier frequency in the upper level. 5 kilohertz is deviated from carrier frequency towards lower sideband. So 5 kilohertz here, 5 kilohertz here in the left hand and right side. So called it's upper sideband and lower sideband. This is how we determine bandwidth of AM. At the same time, phasor representation of AM signal. See, phasor representation, it is nothing but the AM signal, amplitude modulated signal having three components as I have told you, mentioned here. One is a carrier voltage, carrier component, another one is upper sideband component and lower sideband component. When AM signal is a travel, the keeping carrier component, the upper sideband and the lower sideband will be changing its phase, changing its phase. So upper sideband always rotate in the anti-clockwise. Okay, then lower sideband always rotate in the clockwise, keeping carrier component is fixed. That phasor representation showing here. Both upper sideband and lower sideband in opposite direction. This is how we are trying to find out AM, frequency domain, time domain, and phasor representation. From the amplitude modulated signal, we calculate what is power and current calculations. As per the concept in the AM signal, the total transmitted power equal to carrier power into 1 plus m square by 2, where m is the modulation index and the PC is the carrier power and the T is the total power. Okay, PC is the unmodulated carrier. Okay, not modulated, unmodulated carrier. Therefore, the transmitted power PT equal to PC into 1 plus mt whole square by 2, where mt equal to square root of m1 square plus m2 square plus m3 square. Okay, this is the total transmitted power from the amplitude modulated signal. And the current relations in AM, transmitted current which is equal to carrier current IC into 1 plus m square by 2 whole power half. This is a total current which is equal to carrier current in 1 plus m square modulation index square by 2. Okay, this is how we study the amplitude modulated power as well as current and relationship. In this session today we discussed about what is AM, what is different types of AM, and what is a message signal, carrier signal, how it's getting modulated, and what is a modulation index, and how the modulation index varying with respect to different modulation index, how that under modulation and over modulation and critical modulations are happening and occurs, and what is a power current relationship. Next session we study about the different types of AM communications like a double sideband suppressed carrier, double sideband uh, you know full carrier with suppressed carrier, and vesicle sideband AM modulated signal. Then we go for FM signals. Thank you.